going to use rules for differentiating the basic trig functions. Okay, so the first two you're going to learn is sine and cosine. Derivative of sine is cosine, derivative of cosine, negative sine. There you have it. Basic as that can be. Just remember, derivative of sine is cosine, derivative of cosine, negative sine. And then all we're going to do is do little practice ones. Now it's going to make more sense to do quotient rules. So on this one here, this is a quotient rule. So I'm going to allow this to be u. This is equal to u. So u prime is going to be cosine of x. And I'm going to allow this guy to be v. And so v prime, derivative of negative 2 is 0, plus cosine, derivative of cosine is negative sine. And let's not forget our formula is u prime v minus v prime u all over v squared. So u prime v, so I get cosine of x times negative 2 plus cosine of x minus, and then v prime u, v prime times u. So negative sine of x, but it's negative, so two negatives make it positive. Sine squared of x all over v squared, which is negative 2 plus cosine of x squared. Now, a lot of times you can just leave this at this, but when you have trig functions, you have to be able to find identities or look for identities that can possibly reduce this. Now, if I was asking you to find, okay, actually, let me go back. AP test. If it's multiple choice, you need to reduce this down because they will. Free response, they're going to literally leave this alone. If you're trying to find it at a particular value, they're going to let you leave this alone. So I always reduce down because if this was a question on the multiple choice version, you'd have to be able to break it down. So let me distribute my cosine through, and that's going to give me cosine of x, negative 2 cosine of x, plus cosine squared of x, plus sine squared of x, all over negative 2 plus cosine of x squared. And this is where you would be looking at sine squared plus cosine squared equals 1. So my derivative, y prime, so anyways, this guy right here is equal to 1. So I have 1 minus 2 cosine of x all over negative 2 plus cosine of x squared. And we have it nicely cleaned up. Now, again, you get this far, you're correct. But on a multiple choice version part of the test, they will clean this up, and you need to know how to do this. Okay, let's try another one. Okay, this one's product rule, x squared times sine of x. So u is going to be x squared, so u prime 2x. V equals sine of x. So v prime equals cosine of x. Remember, derivative of sine is cosine, derivative of cosine, negative sine. And we want u prime v plus v prime u. So we get 2x sine of x plus, and go this way, we get x squared cosine of x. Done. So don't forget to label things. Y prime equals, and there's your answer. There's nothing more that we can do. That we can factor out an x. It's not going to help us do anything to this. So there, we're done. Another example. Oh, look, another one of these that we get to play with the quotient rule. So I'm going to let cosine be u, so u prime is negative sine. And I'm going to let this guy be v, so v prime equals, now this is 0 minus the derivative of sine is cosine. Now we don't need that 0, but I wanted to make sure you didn't lose that negative sign. So v prime really is negative cosine of x. And our formula, u prime v minus v prime u all over v squared. So we go this way, so I have negative sine of x times 1 minus sine of x minus, and we'll multiply this way. So I have the negative cosine, so let's just write it. So I have cosine of x times negative cosine of x all over 1 minus sine of x. I'm going to distribute now. Again, for response, or they want to add a particular value, you would plug it in. But we're going to clean this up. And don't forget to label. Well, I started writing a dy, so dy dx equals all of this. I'm going to distribute this in. So I get negative sine of x plus 2 negatives, make it positive, sine squared of x, 2 negatives, make it positive, plus cosine squared of x, all over 1 minus sine of x. Ooh, this guy's squared. Can we say oops? Let's not forget this guy. He's squared. Again, there it is, sine squared plus cosine squared. That equals 1. So on the numerator, we have left 1 minus sine of x over 1 minus sine of x squared. So in the end, our derivative is, this is going to cancel out. This cancels out with one of these. So we're left with, by the way, I'm canceling the whole thing out. We're left with 1 in the numerator and 1 minus sine x in the denominator. I tell you what, if we had to do the second derivative, this would be very easy to do. But there we are. Okay, simple harmonic motion. The motion of weight bobbing up and down on the end of a string is an example of simple harmonic motion. You guys have seen these little things. They just bounce up and down. So let's play with a couple of problems. So actually get in there and start doing more things with the trig function. A weight hanging from a spring bobs up and down with position function s equals 3 sine of t. S is in meters, t is in seconds. So we got to make sure we identify our units. What are the velocity and acceleration at time t? So if s of t equals 3 sine of t, then v of t will be 3 times the derivative sign, which is cosine of t. And that is going to be meters per second. And then our acceleration function, again, the 3 times the derivative of cosine. Derivative of cosine is negative sine, so let me put a negative in front of the 3. And this is going to be meters per second squared. Now, I want to point something out because I see this happening all the time with this guy here. So I'm doing the acceleration function. A of t equals, I wrote down 3, and derivative of cosine was negative sine. And I get this a lot. Since they're thinking it, 3 times negative sine, and they write it like this. And it would be my question is, what's wrong with this? Because this is definitely not this answer. Please, you're thinking this is 3 times this guy, but nowhere here are you indicating multiplication. This was read 3 minus sine. So this guy has to go in parentheses. You have to at least do that. And then rewrite it and put your negative sign out front so that this doesn't accidentally become a negative sign or a multiplication. Let me stop. So it doesn't become a subtraction problem. Be very, very careful here. But there it is. What is the velocity function? Velocity function is 3 cosine of t meters squared. And the acceleration function is -3 sine of t meters squared. And yes, as you do more and more derivatives, they just go back and forth between sine and cosine. Okay, so let's look at another one. A weight hanging from a spring is stretched 5 units beyond its rest position, s equals 0, and released at time equals 0 to bob up and down. Its position at any later time is, time t, is s equals 5 cosine of t. What are its velocity and accelerations at time t? Same problem as last time. S of t is equal to 5 cosine of t. They did not give us units on this one. Velocity function v of t is going to be 5 times the derivative cosine. Derivative cosine is negative sine, so I put the negative in front and then sine of t. And then our acceleration function, whoops, that should be t, is -5 times the derivative of sine, which is cosine. And again, they did not give us any units, so there's nothing more to do here. All right, well, I'm going to do the problems. Not that we need to do these. They're the same one over and over and over again. S of t equals 7 sine of t. B of t equals 7 times derivative of sine, which is cosine at t. And acceleration is 7 times the derivative of cosine, which is negative sine. So we put the negative in front of the 7. And they, again, didn't give us units. So the last thing in this part of the notes is going to be jerk. The jerk is the derivative of acceleration if a body's position at time t. So we get our third derivative. Now, this is obviously not jerk like you're a jerk. Okay, jerk is the same as if you're driving a stick shift and you pop the clutch and the car jerks forward. That's the type of jerk they're referring to. So this is the end of day 1. So a quick little one on this one. And then we'll get busy on the next one. Good luck.